Hi everybody, in this video we're going to be going over test number 1. In question number 1, it says which diagram shows the construction of a 45-degree angle. So even if we're not really sure which construction shows that, let's think about where a 45-degree angle can come from. If we start with a 90-degree angle and we bisect it or split it equally in half, we create a 45-degree angle. So let's see which construction here starts off with a right angle, because we know how to construct a right angle. We talked about constructing a perpendicular line through a point, and we talked about constructing a perpendicular bisector. So we know how to create right angles, and we do know how to construct an angle bisector. So looking through the answer choices, this one doesn't start off as a right angle. It looks like it's the construction of a triangle first, and then one of the angles of the triangle is bisected. It looks like it's an equilateral triangle. An equilateral triangle would have 60-degree angles because 60, 60, 60 makes 180. That's not the right choice. This angle over here, well, it might be 45 degrees, but from the construction, I have no way to know that for sure. I'm not really sure what construction this is, where these marks are coming from, but I do see it's not starting as a 90-degree angle and being split in half. Answer choice 3, if you take a look at the first set of construction marks, the arc that hits the line in 2 spots, and then the intersecting arcs above, we can see that that is the construction for a perpendicular line through a point. So that creates a 90-degree angle. And then we have the starting arc over here, and then the intersection arcs to show that the angle is being bisected. So we're starting off with a 90-degree angle. We know it's 90 degrees for sure because it's the perpendicular line construction. And from there, it's being bisected with the angle bisector construction. This last one is a perpendicular line through a point, but nothing's being bisected. So over here, this would be the construction of a 90-degree angle, and then it was connected to make a right triangle. So this is the construction of a right triangle over here. Now the 45-degree angle, 90-degree angle, right triangle. Okay, number 2. We have a right triangle. We know what 2 of the legs are, and we need to find the hypotenuse. On the review sheet, the question on the Pythagorean theorem with the right triangle was even a little bit more difficult because you were given the hypotenuse in that one and you had to work backwards and find the leg. This one's more straightforward because you have the legs. All you need to do is find the hypotenuse. Using a squared plus b squared equals c squared, the Pythagorean theorem, which again is for right triangles, it can help you find the missing side of a right triangle if you know the 2 other sides. Plugging in the legs. One of the legs is 3, the other leg is 5. And remember, the hypotenuse is always c. The hypotenuse is across from the 90-degree angle, so that's what we're finding here. 9 plus 25 is equal to c squared. 34 is equal to c squared. To get c by itself, we're going to take the square root of both sides. The opposite of squaring is square rooting. And we have c is equal to radical 34, which is the answer choice over here. Name an angle supplementary to angle DOE. So supplementary means that together with angle DOE, it's going to make 180 degrees or a straight angle. So DOE, let me try to outline that a bit better. Oops, I'm jumping around on my computer here. Okay, let me try to outline DOE a bit better. There we go. So that's angle DOE. Let's try out the answer choices. So answer choice 1 here, BOD. Well, BOD is a 90-degree angle. So in order to be supplementary with DOE, DOE would also have to be a 90-degree angle because 90 plus 90 makes 180. But I'm looking at DOE, and it's definitely an obtuse angle. It is not 90 degrees. So BOD is not going to be supplementary to DOE. So without even checking out BOE, I already know that that answer choice is not true. Let me try out angle AOC. AOC. Angle DOE is obtuse, so it's greater than 90 degrees. So to make 180 degrees, the angle supplementary to it would have to be less than 90 degrees. Because if they're both obtuse, over 90 plus over 90 would make over 180. For example, if this one's 100 and this one's 120, if we put them together, we have 220, which is over 180. To make supplementary angles, they should total 180 degrees. So two obtuse angles are not going to work. Angle AOB. We have the same issue as we had with the other right angle, BOD. If AOB is exactly 90 degrees, DOE would have to be 90 degrees as well to make 180. 90 plus 90 is 180. But DOE is obtuse, so that's greater than 90. So when we add them together, we're going to have more than 180. So they're not supplementary. Finally, angle AOE. It's an acute angle. So there's definitely the possibility that when we put it together with angle DOE, which is an obtuse angle, we could make 180. And if we take them together, we do have a straight angle, or 180 degrees. Angle COD. Once again, it's an acute angle. So there is the possibility that it would make 180 degrees with obtuse angle DOE. And if we put them together, we have a straight angle, 180 degrees. So we do have our correct answer choice over here. The ratio of two complementary angles is 2:7. So complementary means angles that add to 90 degrees. So we talked about when we were in class, when we were doing the review sheet together, that we can represent a 2:7 ratio. You can represent the 2 part as 2x, and you can represent the 7 part as 7x, and that always works anytime you have a ratio. That was also in the answer key to the review sheet. There was a question exactly like this, same wording, just a different ratio. It was complementary angles. Also, the only thing that was different was the ratio that was given, but it's the same exact thing as what was on the review sheet. So I'm going to make an equation that says, since these angles are complementary, if I add them together, I get 90 degrees. Combining my like terms, and dividing by 9 on both sides, we have our x value of 10. The question is asking for the measure of the smaller angle. So the smaller angle is going to be the 2 part of the ratio. The 7 part is, of course, going to be bigger. 2 times our x value, which is 10, gives us 20 degrees. A lot of people lost points on this one. It was exactly the same as the one on the review sheet. I think a lot of people maybe didn't review the answer key to the review sheet. In bold, it says correct notation is required for full credit, which a lot of people lost points on as well. Name any 2 line segments in the diagram. So line segments are from a point to a point. So I'm going to name BC, and I'm going to put my notation over it, and I'll just name AB. Any 2 line segments point to point, and I'm going to put my notation over it. We name line segments with 2 letters. They have 2 endpoints, so it goes from a point to another point. Name 2 rays that share an endpoint. I see that this ray, and this ray are two rays that share an endpoint. I also see that this ray and this ray share an endpoint. So we have a lot of options here, but we only need to name one pair of rays that share an endpoint. So I'm going to start off with this one over here. Remember that since rays have an arrow on one end, we do have to name in the direction of the arrow. So this ray is starting at point B and it's going towards A. The arrow is pointing in the A direction. So starting at B, going towards A, that's ray BA with my ray notation. This ray over here, B is at the point, it's starting at point B, and it's going in the C direction. The arrow is in the C direction. So we can name this ray BC with our ray notation. Next, we have to name the line in two ways. There's only one line here. Notice the double arrows on both ends. So you can name a line with any 2 points that are on the line. So I'll name it line AC. And I'll remember my line notation. And then another good name would be line BC. B and C are 2 points on the line. Once again, you can name a line using any 2 points that are on that line. Just remember your notation. D, people didn't really have trouble with. I'm going to name an angle in the diagram. I'm just going to name angle, let me highlight it in yellow, angle ABE. And I'm going to put my angle notation, 3-letter names for angles, remember. And the angle that I named is obtuse. Be careful. We don't have any boxes on the angles that look like right angles. And we're not told anywhere that we have right angles or that any lines are perpendicular to each other. So be careful. So those of you who made an assumption that angle EBD was a right angle or that angle EBF was a right angle, I don't think we have reason to believe that here. For the next one, I'm going to just graph the triangle real quick so you can get a better picture of it. That's -1, 1. That's 4, 0. And that's 0, 4. The question in part A, we're going to take it part by part. Part A is saying, prove that ABCD is an isosceles triangle but not an equilateral triangle. While you guys were taking the test, on the board, it said that an isosceles triangle has 2 equal sides, while an isosceles triangle has all sides equal. So basically, what we want to show here is that this triangle has 2 equal sides, but there's a side that's not equal, making it not totally equilateral. It's just isosceles. So I should write my conclusion now, since I know what I'm trying to show. What I'm going to try to show is that 2 sides of triangle ABC are congruent, but not all 3. A lot of people left the conclusion blank, but you can write what you're trying to show, the conclusion that you're trying to draw, even if you didn't know how to get there, even if you didn't know what calculations to do to get there. So now let's actually show it. Let's actually show that 2 sides of the triangle are congruent, but the third part is not. To show lengths, because we want the length of the side, the length of the side, and the length of the side, we use distance formula. I'm going to write my distance formula down. You do need to know it. It will not be given to you. It comes up a lot in geometry throughout the whole year. It's given on tests or on the Regents exam. And a big hint, if you remember our notation, that you need to use distance formula here, is that when you see 2 letters for a line segment, BC, AB, AC, without the bar on top, so without that little bar on top, remember it means that we're talking about the measurement of BC, AB, and AC. And we find the measurement of a line segment using the distance formula. The length or the measurement, how long it is, that's distance. The distance from one point to another. Let's plug in. I'm going to be able to see my points while I plug in. There we go. So for BC, I'm going to use points B and C. Try to fit this as best as I can. So my x values are 0 and 4. My y values are 4 and 0. 0 minus 4 is negative 4 squared is 16. 4 minus 0 is 4 squared is 16. We have radical 32 for the length of BC. Next, let's do AB. Using points A and points B, my x values are 4 and negative 1, so that's 4 minus negative 1. My y values are 0 and negative 1, so 0 minus negative 1. 4 minus negative 1 is 5, squared is 25. 0 minus negative 1 is 1, squared is 1. We have radical 26. For the length of AC, let me get a different color so it's not confused. Here's point A and point C. My x values are 0 and negative 1. My y values are 4 and negative 1. Zero minus negative 1 is 1, squared is 1. 4 minus negative 1 is 5, squared is 25. And we have radical 26. So here we see that we have showed the conclusion that we were trying to reach. Triangle ABC is isosceles because it has two equal sides. Sides AB and AC are both radical 26, but it's not equilateral because it has one side that is different. Side BC is not the same as sides AB and AC. So in the triangle, I could mark side AB and side AC as being congruent to each other. And that means it's isosceles, two equal sides. The second part of the question, part B, is asking you to find the midpoint of each side of the triangle. I don't think I could have been clearer with find the midpoint. Find the midpoint means use midpoint formula. I don't think that could have been written out more clearly. Let's find the midpoint of each side. So my midpoint formula, I'm going to write it over here, midpoint formula. It's the average of the x coordinates, comma, the average of the y coordinates. You do need to know your midpoint formula. Once again, not given to you. You do need to know it. It comes up throughout the whole year. Remember the comma in between? We talked about how a midpoint is a point. It's an ordered pair. It's in the word point. So it should be coordinates at the end. So for BC, let me look at my points again. My x coordinates are 4 and 0. 4 plus 0 over 2. My y coordinates from BC are 0 and 4. 4 plus 0 over 2 is 2. 0 plus 4 over 2 is 2. So we have the midpoint of side BC. Now let's do AB, and I'll use a different color. The x values are negative 1 and 4. The y values are negative 1 and 0. That gives me 3 over 2 and negative 1/2. You can write it as decimals. I just prefer to leave as fractions. Why do more work than I have to? It's equivalent. In fact, sometimes fractions are better because sometimes decimals like go on and you can't tell if you're rounding, if they leave your calculator screen, if they keep going to the end. So sometimes fractions are better to make sure that you get the exact value. Okay, for points A and C, the x coordinates are -1 and 0. And the y coordinates are -1 and 4. That's -1/2, comma, 3/2. And that's the end of that question. We've answered part A completely, and we've answered part B completely. We found the lengths of the sides, showing that it's isosceles and not equilateral. And we found the midpoints of each of the sides. In this one, we're told that ray MO is bisecting angle LMN. So if we have an angle bisector, we know that the angle is being split into two equal or congruent parts. LMO is 15x minus 42, and MNO is x plus 56. NMO, sorry. Since we know that the angle is being split by the bisector into two equal parts, we can make an equation that says this half of the angle is equal to this half of the angle. Now all we need to do is solve for x. Subtracting x from both sides, I have 14x minus 42 is equal to 56. Adding 42 to both sides, I have 14x is 298. And then finally, dividing both sides by 14, we have x is equal to 7. So that's part one, the x value. Now we need to find the measure of angle LMN. LMN is the whole angle. So what we need to do is plug into each part and then add together to find the whole. So I'll plug it into this part first. So we have 15 times our x value of 7 minus 42. 15 times 7 is 105 minus 42 is 63. So we have 63 degrees for angle LMO. Since the angle is being bisected, the other half of the angle should be exactly the same. And if you wanted to verify, you could always plug your x value of 7 in for the other angle. 7 plus 56 gives you 63 as well. 63 plus 63 to get the whole angle is 126 degrees. For the next part, we need to construct the angle bisector of angle MJH. Let me get my compass out. Okay. I'm going to start off with my compass on the vertex of the angle, which is angle J, well, point J here. It doesn't matter how far I open my compass. I just want to make an arc that intersects the angle in two spots. So notice how my arc here intersects the angle in this spot and this spot in two spots. So you want to make an arc that's on the angle. We call that our reference arc. I'm going to put my compass on one of those intersection points. I'm going to try to be as accurate as possible. On the computer, it's a little hard to be accurate. Much easier by hand. I'm going to open up a little further. It doesn't matter exactly how wide. And then I'm going to just swing an arc. Keeping the same measurement, since I am bisecting, whatever I do the one intersection point, I have to do to the other. I don't want to change either how far my compass is open or the hole I'm using if I'm using the red compass. I'm going to move over to the other intersection point. Oops. This doesn't want to write. There we go. And I'm going to make the same arc using the same hole or the same distance if you're using a compass like me. Using my straight edge, I'm going to start at the vertex, and I'm going to go straight through the intersection of those two arcs, and it should cut the angle exactly in half or bisect the angle. So we have two congruent parts here. Leave all your construction marks. Do not erase any arcs. Otherwise, you will not get full credit for the question. So in total, this was 3 arcs. The first arc on the angle, that's the reference arc. And then the 2 other arcs, one with your point on this intersection point, one with your point on this intersection point. That's it, 3 arcs, and then you just use your straight edge and draw a bisector right through. Number 9. We need to construct the midpoint of the line segment. So if we're constructing the midpoint of the line segment, the midpoint is the middle of the line segment. So we want to cut the line segment in half. So another word for cutting something in half is bisecting it into equal or congruent parts. So what we want to do is we want to bisect the line segment. Remember, we learned about the construction called perpendicular bisector, and it's also in the construction video that's posted in Geometry Resources on Google Classroom that goes over the 4 constructions that we've learned about so far from class. Not only does the perpendicular bisector bisect or cut equally into 2 congruent parts, it also is perpendicular, so it creates 90-degree angles. But for this question here, we're just interested in the cutting in half part. So I'm going to take my compass and I'm going to put it on one of the endpoints of the line segment. I'll just put it on point A first. And I'm going to open up. The exact distance doesn't matter, but I want it to be more than halfway down the line segment, about 3/4 of the way. And I'm just going to make an arc. I made mine pretty big. The reason for that is at the end, we want to see an intersection of our 2 arcs at the top and also at the bottom. So you don't have to make your arc go all the way above and below, but for me, it's just easier to do that. Without changing the distance that my compass is open or using the same hole if you're using the red compass, we're going to go over to point B and we're going to do exactly the same thing, make the same arc. We need to make sure that we're using the same distance or the same hole if you're using the flat red compass, because since we're bisecting or cutting equally in half, if we change that length or that measurement, we're not going to end up with 2 equal parts. So I'm going to take my compass and move it over to point B. And I'm just going to make the same exact arc. Notice how I have an intersection point above and below the line segment. What I'm going to do is I'm going to take my straight edge and I'm going to go from one of the intersection points right through the other as best as I can. And I will label this point the midpoint. We know it's the midpoint for sure because we constructed a perpendicular bisector, which bisects the line segment or cuts it equally in half into 2 congruent parts. So point M, the point that we constructed here, where the bisector hits the line segment, is for sure the midpoint. One more question to go, and then I will go through the extra credit really quickly for those interested. So we have line segment AB, BC, and AC. So AC is the whole thing, it's 24, and the parts are AB and BC. We have the pieces, what they're represented as. I'm going to draw myself a picture. Here's line segment AC, and point B is somewhere in between. I don't know if it's the middle. That's the question we're trying to answer. Is B the midpoint of AC? AB is 3x. BC is x plus 5. Well, if this point is in the middle, this should equal this at the end. Since I don't know if it's the midpoint, I can't just set up an equation that says this is equal to that because I don't know that that's true. What I do know is that this part from A to B is 3x, this part from B to C is x plus 5, and the whole thing, AC, is 24. And I do know that if I add the parts together of a line segment, I get the whole thing. That's the partition postulate. So I'm going to make an equation that says if I add this part of the line segment 3x to this part of the line segment x plus 5, I get the whole line segment 24. Combining my like terms, I have 4x plus 5 is equal to 24. Subtracting 5 from both sides, 4x is equal to 19. And dividing by 4 on both sides, we have x is equal to 19 over 4. It's not a pretty number. Let me plug it in. You can find the measurement of each part of my line segment of AB and BC. So I'm going to multiply 3 by our x value of 19 over 4. Putting into my calculator 3 times 3 times 19 over 4. And I got 14.25 for the length of AB. Plugging into BC, let me do 19 over 4 plus 5. 19 over 4 plus 5. And I got 9.75. So we see here that B is not the midpoint. B is not the midpoint of AC because AB is not equal or not congruent to BC. If it was the midpoint, it would be splitting the line segment equally in half into 2 congruent parts. They would be the same measurement. Okay, so the extra credit was to construct completely with a compass and straight edge a 135-degree angle. So that means the whole thing has to be fully constructed. So I know a 135-degree angle can be made by taking a 90-degree angle and adding 45 degrees to it. 90 plus 45 is 135. So I'm going to start off by constructing a 90-degree angle. So I'm going to just start off with the line segment. And I have 2 options to construct a 90-degree angle. I can do my perpendicular line through a point construction. I can make a point somewhere and make the perpendicular line to it. Or I can just do a perpendicular bisector. Since there is no specified point here that it has to be drawn through, I think perpendicular bisector is the easier route. A lot of people like that construction better. So what I'm going to do is I'm just going to open my compass more than halfway, about 3/4 of the way down the line segment, and I'm going to construct my perpendicular bisector. Arc above and below. Then, without changing the measurement that it's open to, I'm going to go over to the other intersection point and use the same hole if you're using a flat compass. And now I have my top and my bottom intersections. Through the 2 intersection points, with my straight edge, I'm going to draw my bisector. And since this is a perpendicular bisector, perpendicular lines do form 90-degree angles. So 90-degree angles are formed at the intersection. So I have a 90-degree angle here, a 90-degree angle here, a 90 here, and a 90 here. So to make 135, I need 90 plus 45. If I have a 90, I can get 45. I can make 45 by cutting it in half. Half of 90 is 45. And luckily, we know how to construct an angle bisector. So that's what I'm going to do. I'm going to bisect one of the 90-degree angles. I think I'll just bisect this one, and I'll leave this one as 90 degrees. So to construct an angle bisector, what I'm going to do is I'm going to start off with my compass point on the vertex of the angle that I'm trying to bisect. So this would be the vertex of this 90-degree angle that I'm trying to bisect. Let me use a different color so we don't get confused with all the construction marks. So remember that the exact length doesn't matter that I open the compass to, or the exact hole doesn't matter. I just want to make an arc that hits the angle in 2 places. And notice how my arc here intersects the angle here and intersects the right angle over here. So it intersects my right angle in 2 spots. Now what I'm going to do is I'm going to take my compass and I'm going to go over to each of those 2 intersection points that I marked in yellow. I'll just go to the top one first. Just going to open my compass a little bit more. The exact measurement doesn't matter, really doesn't, or the exact hole doesn't matter, just a little bit more. And I'm just going to make it arc. Since I'm bisecting, I have to use the same distance or the same hole on the other intersection point. So I'm going to be careful not to move my compass. I'm going to come right over here to the other intersection point, and I'm going to make the same exact arc. starting at the vertex of the angle, let me actually make this a different color so we can tell it's different than the bisector at the beginning. So starting at the vertex of the angle through the intersection point of the arcs, I'm going to draw my angle bisector. And since we bisected the angle is being split into 2 equal parts. So this is 45 and this is 45 because it started as a 90-degree angle. So this is 45 degrees. So since this one's 90 and this one's 45, these two angles together are 90 plus 45, which makes a 135-degree obtuse angle. This angle here.